Thank you very much, everyone, for being here. My name's Alex Crandall, and I'm here to talk to you about designing secure protection environments with Veeam and AWS. So, protecting your environments is critical these days, especially with, if anyone reads the news, which I'm sure we all do, is ransomware is everywhere. It's not a matter of when you're going to get, if you're going to get hit, rather, it's when you're going to get hit. So making sure that your environments are designed with best practices in mind, segmentation of roles, and leveraging technologies out there in the market today like Object Lock to protect your data becomes critical when malicious actors get into your environment. Now there's a couple statistics up there, and a keen eye observer would see that PDF actually links to a document from 2021. So earlier I actually went and the 2022 document is out, and as it should be no surprise to anyone, a lot of those numbers have gone up. So if we're looking at the average ransomware paid as an example, that went up 4.8 times. So it's close to $800,000 now. And one thing in particular that I noticed in that report was organizations who had proper backups and were able to recover, that was around the 75% of those organizations were able to get back up and running and recover all of their data. Now, we all have this concept in our mind. It's like, that happens to someone else, it doesn't happen to me. But the reality of the fact is, anyone trying to get into your environment has infinite amount of opportunities, be it through misconfigured edge device, the human factor, or simple things like phishing emails. They really only need that one opportunity to get into your environment and start causing malicious harm. Whereas we as the sysadmins or people taking care of these environments have to be aware of these things and make sure that our infrastructure is up to date, it's patched, things are functioning as they should, because it could be something simple as one missed alert when you have an unauthorized access on a file or a particular port. That can make all the difference in your environment. I kind of talked a little bit about, and you can see as the slide builds out, there's all these gears. So these are all important things inside your environment that keep you safe, or the opposite in most cases, because it's telling you what can happen. But if any of these gears fail, something happens, you're at risk. So I was talking about getting alerts for things like unauthorized access to particular systems, files, ports. What do? They generate alerts. Where do those alerts go? Now, I shouldn't say this because my manager is standing right there, but I get a lot of alerts day to day, and I am very creative with my Outlook email filters. So, sorry, Rick. But at the end of the day, some of them I know, searching for certain keywords, do I need an alert for that? No, probably not. Am I just on that distribution list because I fall into it? Yes, I am. But for things like critical things like I was saying, unauthorized access, maybe you have some SLA policies failing on certain infrastructure, or maybe you have entire container environment, nodes, or virtualization hosts down. Those are the kind of critical alerts that we want to make sure that we're keeping track of. Now, missing patches, that is, that's kind of the elephant in the room, because there's been far too many reports lately about organizations where how the attackers got in was from a system that wasn't patched, and it was a known vulnerability where there was a remediation patch for it. So just making sure that those small things, it used to be Patch Tuesday, well, now they're just coming out all the time. But making sure that those systems are up to date and protected is also key. Now, poor password policies, I think we all know someone who shares around a password too much. I'm sure we've all used someone else's Netflix at some point. I don't see anyone from Netflix here, so I'm pretty safe to say that. But if I think of even in my own life, I have parents, and do they use the same password for some things? Absolutely. Now, we're not to that passwordless society where everything is doing device IDs, biometrics, or those, but simple things like password managers remediate a lot of that issues. But how many times in an environment do you have a legacy application that has a service account with some large amount of privileges to a large data set that, when's the last time that password has been cycled? So making sure that these things stay cycled and up to date is also key. Lack of network segmentation, that's pretty straightforward. In my previous lives, I've dealt with a lot of companies where things like a DMZ didn't exist, and they had access directly into certain servers for web applications. And maybe those web app servers had a few too many services running on them. So being able to segment things into basically your different zones. So, your DMZ, your production, your management, and your backups, keeping those all separate and making sure that you have those delineation of not only access, but roles through that segmentation will help protect you in the long run. Now, one that's obviously near and dear to my heart is untested backups and slow restore time. So what good is a backup if you've never tested it or you don't know if it's gonna work for you in the event of an emergency? It's basically, at that point, not worth the paper or the disk space it's stored on. So being able to do things like automation and schedule those backup testing to be able to ensure that not only at a file level, but at a volume or an OS level, that those workloads are backed up in a consistent manner and a recoverable manner. And then slow is, ultimately when we look at the different types of workloads, if we're talking, databases or critical pieces of infrastructure, being able to get those back up and running as quickly as possible is key to the organization. Misconfiguration, if anyone, if you know me, I'm not the best speller. That's why I'm not in programming any longer, because I had a bad tendency of misspelling variables. So I try to avoid that at all costs, and it's a simple thing like not commenting out something properly in a configuration or a wrong number in an IP address can make a world of difference when we start talking about that misconfiguration and bad actors getting in. And inconsistent policy, the final kind of cog in the wheel, is that inconsistent policies between data center and cloud. So traditionally, when you start talking about data protection in data centers, it was kind of a monolithic approach. Most people said, hey, I have 7 years of yearly backups, I have so many monthlies, so many weeklies, and let's say 7 or 14 dailies. Now that sounds great in principle, but if you're a sysadmin and you go back and say, well, do I really need to recover from a backup of an Active Directory server from 6 years ago? The answer is, unless you're in a very specific audit, no. You would always go to something more in the last few days or maybe a week out, because ultimately that's going to give you the better picture of what the environment looked like at that point. Not only that is trimming that down, and not all data is created equal, is when you get a little more strategic with those policies, you're able to save on storage space ultimately. Because if as in that example, that was great when you just had, a low-level guy driving out to a colo site somewhere, grabbing a tape, putting it in his car, and taking it wherever. But when we start talking about how much more space those data consumed, or that data consumes rather, nothing is getting smaller from a workload perspective. I have done far too many projects where organizations in my previous life went from a traditional file share on a server in a data center somewhere to Microsoft Teams. And they went from maybe 5 or 10 gigs of storage, same with mailboxes, to basically using it as a file system or OneDrive. People have a terabyte there now, and some people do some creative things. Now, from a best practices perspective, these are some high-level things that you can do in your environments today, be it data center, public cloud, or software as a service offerings, to help make sure that you can recover and you can get back up and running in the event of something happening. So backup is always going to be that, in case of emergency, break glass feature. It's ultimately what you want to use as your kind of last line of defense, because obviously if you can catch them in the act or remediate it right away, then you reduce that attack surface, and anything that you need to recover becomes a lot smaller and a lot quicker. So identifying, in particular, data tagging. So if we're talking data tagging, data locality, kind of go hand in hand, but making sure that from a tagging perspective, if you have certain level of SLA requirements for those workloads, tagging them appropriately and making sure that they're assigned to the proper policy, make sure that they're backed up at the correct interval, they're tested, and you can use those tags dynamically within different types of jobs to then automate a lot of this process out for you. Data locality, obviously, we're here in Ottawa, there's different data centers through central Canada, and if you don't want that data, egressing to a US data center or even from AWS itself or your data center, you can add those location tags that if something is copied outside, you start getting alerts, or you have IDP policies in place so to make sure that that data stays consistent across. And then finally, putting that all together with Business View. So you have all the data, you know what data is being tagged with which, you know where it's going. How does that tile together? Now, from a protection perspective, Veeam for a long time talked about our 3-2-1 rule, which is 3 copies of data, 2 different types of media, one of those being offsite. Now, someone decided to add an extra 1 and a 0 on there, and I'll talk about it in a subsequent slide, but that's talking about making sure that one of those copies is either air-gapped, immutable, or offline, and the 0 making sure that there are 0 errors inside your backup. So I talked a little bit about that testing and making sure that data or those backups are consistent and recoverable. That ties into that 0 rule. So immutable storage. I mean, we're at AWS's Summit. Obviously, your best defense there is their S3 API lock, or lock API, sorry. So what that's going to do is when you put data either from cloud native instance backups or Amazon Elastic File Services, your Kubernetes EKS backups, putting them in that S3 bucket allows you to tag them with that object locked API and make sure that they're immutable for set periods, be it maybe 7 days, 30 days, even up to 90 days. I think that slider can go all the way up to 99 years if you really wanted to. Although if you're retaining something immutable for 99 years, I'd love to hear about that use case. And then you can see the Sure Backup and Sure Replica. So inside Veeam, that's a technology we use to make sure that Sure Backup will actually take those backups of whatever workload it is, bring it up into an isolated environment, and then run specific testing scripts or custom testing scripts against that workload to verify functionality of, say, a specific SQL database or Postgres database, any SharePoint, Active Directory, kind of the built-in ones, and then, again, the custom scripting allows you to get in there a little more granularly and test against specifics. Sure Replica, same idea, except for replicated virtual machines between 2 environments. Now, detection is obviously one of the most powerful tools in your toolbox, and that's going to allow you to see what's happening in the environment today. So when we think of things like ransomware, what happens is your system gets infected, and if it starts going out to encrypt files or does some east-west traffic, you're going to start to see high CPU usage and high disk usage. So those are those kind of alertings and metrics that you can take away, have those sent to either a SIEM product or whatever you're using in your environment. This can all done through the second piece, that API push, and get alerts to say, hey, we're seeing this activity on these virtual machines. If this isn't expected, you should look into it. Now, once you're detected, what does your response look like? So if you do need to get back up and running, what is that orchestration piece? So making sure that you have plans in place to be able to bring up workloads in the proper order, make sure they're verifiable and testable, and also give you dynamic documentation around that. So it's one thing to have these plans written on a Post-it attached to your monitor, but actually having that data in a document that can be dynamically updated and in case of an audit or anytime you need to prove that these things work, you can then leverage this dynamic documentation that's going to tell you things like, this is what your RTO, RPO are expected on this set of applications. If you divide it up by, say, tags or VApps, you can do it that way as well and get a breakdown of all the tasks, all the steps it performed to do these verifications. And if all else fails, the recovery process. So when we start talking about that top point, secure restore, what we're actually able to do is take the backups that we have of a particular workload, be it virtual, physical, container, and run those tests against them. So we can bring them up in an isolated environment. And if you have an existing XDR solution, you can leverage that to then scan that workload for maybe an already known malicious software, because this could be a backup from yesterday, a week ago, a month ago. And maybe the definition for that particular piece of malicious software is now known by the vendor. That virtual machine or whatever can be scanned, and if it's found, you have options to do either manual remediation, so you can have it basically finish doing the restore in this isolated environment, not connected to any network, and then you can access it from a console, perform manual remediation, or if it detects it, you can have it just completely stop, send you an alert for that, and then you can do manual remediation from there. Now, incident level item recovery and instant recovery itself kind of go hand in hand, or sorry, item level recovery and instant recovery. So item level being able to go into your environment, take out specific files, folders, or indeed entire volumes, and restore those to an original location, a new location, or just get basically files out there to an end user. The nice thing here is when we start talking about that or any type of those recoveries, they don't need to be to the original location. So if you're in a transition today from traditional data center to AWS as an example, any of those workloads you can take from the data center backup and restore them directly into a native EC2 instance. So if you're in that decommissioning process of local data center and want to get to AWS a little faster, you can leverage those backups you already have. Now the instant recovery piece is where we're able to actually take those backups and mount them inside a hypervisor so you can get those back up and running in, generally speaking, under a minute. And then Data Labs, that last point, it's what we use in the background to do things like secure restore or that SLA validation and produce basically all of those metrics that allow you to go to management and say, yes, we have this plan, it's tested, here is what our timings look like, here's how long it's expected to take, and what our RTOs and RPOs are. Now I talked about it on one of the points on the previous slide, but the 3-2-1-1-0 now rule is those 3 different copies of data, so be it the initial instance, one backup copy close to it, and then a secondary copy elsewhere. Now the 2 different types of media, there it lists disks and a VHS tape, but that could be very secure because to recover from a VHS tape, I need to go to a pawn shop and actually find one, so that's actually not bad. And then the one is that offsite copy. So when we start looking at what that offsite copy looks like, traditionally in the past it looked either a local disk target in a colo facility or another location, or you were going out to tape. But today you could then start leveraging things like S3 or Storage Gateway. If you needed to get a large amount of data offsite quickly and wanted to ingest it in Amazon, you can look at things like Snowball as well. So doing a copy there, sometimes, depending on the environment, the bandwidth of a truck is still more than your internet connection. So if you have large amounts of data, leveraging things like Snowball to get it there and then tie back into it once it's in your primary S3 bucket is a powerful tool to be able to leverage. And then those new ones, the 1 and the 0. So the 1 being that immutable, offline, or an air-gapped copy. So tape, air-gapped, immutable, S3 API lock, or offline, generally that's going to be your tape as well. Now the 0 errors is where we're going to talk about that verification process using things like Shore Backup, Shore Replica to be able to automate and test those backups and replicas to make sure that, again, when you need them, they're there and ready to go. So the S3 API, S3 object lock is what we use in Amazon today on any type of the tiers that's supported. So we have primary S3, infrequent access, single zone, Glacier, and Glacier Deep Archive. So as you transition data from either EC2 instances or maybe traditional VMware infrastructure into Amazon for long-term storage, you can leverage that API lock to make sure that data is remaining almost similar to how you would for tape. So if you have a monthly tape, you can say, hey, I want to set my object lock for 30 days. Then what you can also do is once you get to those longer retention points in your kind of traditional GFS structure, you can leverage the API lock for those long-term copies as well. So if you need to keep things like monthlies and yearlies for, let's say, monthlies 12 months as an example, and then the yearly 7, when that data starts transitioning down from those hotter tiers down to those Glacier and Deep Glacier tiers, you can also mark those recovery points as immutable for that set period. So monthlies you could set immutable for 12 months, yearlies for 7, and leverage that similar to how you would basically think of tape, except it's online and you can recover from it. Now, isolating environments, so production and protection. So production obviously is going to be those production workloads, and you could have multiple, as an example in AWS, you could have multiple subscriptions. You could have production, you could have dev QA, you could have testing. You also could have that separate subscription for your data protection, and all your data protection infrastructure could live there, be it the storage, any instances that you need to deploy, or even your key management service for any of the infrastructure associated with it. So being able to delineate where that data goes and where those services run protects you in the event that maybe an account on the production side gets compromised, but those accounts don't have any ownership or access to anything in that protection subscription. So it's this extra layer of protection to make sure that anyone that might get access to that production or other subscriptions can't go east or west across and get at your data protection. Now, least privilege access is always the smart thing to start as a base. You don't need to give things more permissions than they actually need. And when you think from a legacy perspective, we used to have a service account in Active Directory. It had global admin. That's what we put into the software, and it accessed everything. You could do whatever you want, and if that account got compromised, it was a bad day. What we're able to do now with the APIs available between RBAC and IAM is basically break down and create specific roles for specific accounts, or get a little more granular on how we need to access things. Because maybe the IAM user that I have doing my EC2 backups, I don't want that touching any of my RDS infrastructure. So you could delineate how you're protecting those based on the account that you create. And obviously, you always want to start very small, and then as more permissions are required, add those as needed. Now, these is just other considerations. So multi-factor authentication, obviously, that's a no-brainer these days. But one thing is, in addition to multi-factor authentication, is you can use third-party identity provider solutions. So in the case of our cloud native solution for AWS, you can tie in any identity provider that supports the SAML 2. You have role-based access control within that. So you can add any users from that identity provider and give them specific access. So me as an example, I might need full administrative rights because I'm adding new S3 buckets, I'm changing worker configs, or I'm just doing the general maintenance. Whereas someone who's a tier 1 at my support desk, they're getting a call in and saying, well, someone deleted something from this EFS share or from this EC2 instance. They, in reality, don't need access to be able to modify a SLA policy or create new workers or do any of these things. So I could assign them that lower just restore operator role where I would have full administration. And then key management. That is also one of the key to the kingdom, so to speak. So when you're looking at the key management, you can tie in your AWS KMS into your data protection solution. So not only can you use that for decrypting and encrypting data at rest, but also if you're using any kind of encryption on your EBS volumes today, we can interact with the keys inside Key Vault to be able to obviously read that data at a granular level. And when it comes to the restore process, use those same keys to be able to open up those EBS volumes and get data at a granular level out if that's what's required. Now, when we start looking at legacy backup versus cloud native backup or platform native backup, legacy backup would be, you're deploying agents to, each instance. You're managing all the patching. You're pushing those out. Whereas what we're able to do now with platform native is use the APIs available through AWS as an example to trigger the actions that we would need. So instead of interacting with a hypervisor, or if it was an agent base, we're interact with a volume shadow copy on a Windows machine, we're going to do that through that native API. So we're going to trigger those EBS snapshots. We're going to use that technology to process it out to a long term on a worker. So reassign that volume to that worker to process off, then to that S3, and then eventually off to S3 Glacier. What this also allows you to do is it gives you far more powerful auditing when it comes to how things are interacting. So if I'm that backup service account, I start communicating with the AWS backplane to trigger those snapshots. All of those things are going to be logged inside, and you can go back and audit it. So it gives you a lot more peace of mind that your software that you're using for the protection is only using those APIs that it requires. Now, from the broad spectrum of protecting your data, obviously we want you to be able to protect that how you need it and restore it where and when you want it. So for things like cloud native backups, those EC2 instances, your RDS databases, your EFS file shares, all the way down to just VPC config on your network. That's actually come in handy quite a few times. I had a customer recently where someone went in and made a change to a VPC config. All of a sudden, no instances could communicate with each other. So what we were able to do, because they kept their backup infrastructure in that separate subscription, we were actually able to go back and do a compare of what the last backup was, or a couple backups ago when it was working, versus what had changed. And we could see at a granular level that, I believe it was either a gateway or a mask was changed, and we were able to restore that and get them back up and running within a few minutes. Now, cloud mobility, this is great if you need to restore anything cross-environment, or like I was saying, if you wanted to take something from your traditional data center, maybe it's a physical server, take a backup of it, and then use that backup to restore it into that native EC2 instance inside AWS. Now, from a SaaS perspective, there's a couple listed at the bottom of the graphic there. Microsoft 365, obviously a big one. And although it hasn't been officially announced when it's going to come out, we do have a product that will soon back up Salesforce, and we should expect that before the end of the year. There's announcements that are going to be made for it at Dreamforce actually later this month. And then the new kid on the block, Kubernetes backup. So from a Veeam perspective, we have a product called Kasten that would handle that, and it will interact with your nodes and back up numerous parts of the infrastructure there, not only the workloads themselves, but things like volumes, the configuration of the nodes, and all the associated information that, not only is it if a container goes down, but if a node goes down, you can also recover from that. If you're going from, let's say, Red Hat OpenShift in your data center and you wanted to restore that into your EKS cluster inside Amazon, you also have that option. So kind of tying back into that mobility where you can take your data and restore it to where you need. Now, I talked about the S3, the APIs that we use there for object lock, but obviously that is going to be where your backup and archive are going. So when you start talking about those short-terms and long-term retentions, whether it's S3, it's an S3 infrequent access, and moving that data down to those longer storage tiers like archive and deep archive. And again, with the S3 API, the ransomware protection being able to use that object lock. So from a Veeam perspective, here is a long list of all the services that we integrate inside of AWS today. Just going around, picking on a few, the KMS I was talking about, object lock. I mentioned about the Snowball Edge. You actually have, if you've been up on the third floor and saw the show floor, they have the big Outpost rack there. We integrate with AWS Outpost as well. So if you have that in your data center and you want to protect data and move that to a primary S3 region, you can absolutely do that. And then on the left, you can see kind of those infrastructure pieces that I was talking about that we would interact and support. So your EC2, your EBS, your RDS, EFS, EKS, ECS, and the VPC one, as I was saying. So that kind of wraps it up for me. That was the kind of 5 and a few extras in there about basically designing those modern protection solutions and making sure that you can recover in the event that something happens. Hopefully never anything does, but if it does happen, the important thing is that you're prepared, you have that documentation, and you have the verification in place to make sure that you can get back up and running as quickly as possible. So thank you very much.